Hi everybody, and welcome to Design a Custom Performance Max Pipeline. I'm your host, Devin Chasanoff, and I've got a special session lined up for you. If you've tuned into the workshop sessions from earlier today, I'm hoping you now have a broad and deep understanding of Performance Max from the developer perspective. In this session, we're going to tie these concepts together by applying them in a hands-on demonstration during which I'll show you how to design and build your own custom Performance Max interface and pipeline. Let's start by outlining some goals for the session. First, if nothing else, this session will reinforce and tie together various Performance Max concepts that we've covered throughout the day. Second, I want you to understand various design considerations to factor into your implementation. If you haven't started development yet, this will be extremely beneficial to your planning, and if you have, perhaps this will give you some ideas to refactor your existing code. Third, I want to reinforce concepts around what constitutes a valid serving Performance Max campaign, so that you can get your campaigns up and running more quickly and with fewer errors. Finally, I want to provide a model demonstrating best practices that you can follow in building your integration. In order to achieve these objectives, I'm going to walk you through a small application I created that uses a simple JSON file to create a Performance Max campaign, or rather, to create one or more Performance Max campaigns. I'll be showing code on the screen, but I may move through it quickly, and I won't be explaining every line. You can always pause the video and go back, but for today, I want you to focus on design decisions and application flow, which is where I'll be focusing. You can think of this as an exercise in applied system design that implements a PMax-specific interface or a shim layer on top of the existing Google Ads API. We'll start with an asset upload pipeline, which is almost like a separate pipeline altogether. We suggest uploading assets in separate requests from those that create the actual Performance Max campaign. More broadly, we recommend uploading assets that may be used in PMax campaigns to your Google Ads asset library, then selecting a subset of those assets from your library in the campaign creation process. That's not to say you can't upload assets and add them to an asset group in the same request. In fact, I'll show you how to do just that. However, uploading the assets ahead of time can simplify the campaign creation process and set you up to leverage Google AI's ability to automatically create assets in your account that you can use in your asset groups. While I'm not going to be overly prescriptive on this point, there's a lot going on in the world of AI and generative assets with new advancements every day. It's wise to set up your infrastructure in a flexible way that can leverage future capabilities. The next part of our pipeline is campaign input generation. With the exception of asset selection, this part will largely be your job, because this step is effectively choosing the inputs for your campaign, and that's dependent on your business goals, campaign objectives, and your infrastructure. However, I will walk you through a suggested process for selecting assets that meet required specifications. More on this later. Once we know our inputs, or have a process for choosing them, we'll create what I'm calling a flattened schema. And you can think of this schema, which I'll be showing in JSON, as our PMax specific interface. This schema simplifies many of the concepts related to PMax by clearly modeling the campaign structure, removing configuration options that pertain to other campaign types, and assuming the configuration options required for a PMax campaign specifically are a given. As I'll demonstrate, you can also create your own custom configuration options for enhanced flexibility. One of the things I love about this approach is that it provides you a consolidated view of your entire PMax campaign that's really easy to understand. It also makes it much easier to validate your campaign, which is a great segue into our next process. While you could theoretically skip this step, I would highly recommend you build something like this into your PMax management pipeline. By doing so, you'll submit fewer failed requests. More importantly, with client-side validation and error handling, you can more clearly understand errors in your PMax campaign that are easy to fix. You can even build a mechanism to address these errors into your pipeline so you can create a PMax campaign incrementally, only submitting it once your campaign is valid. The next step in our pipeline is request pre-processing. In doing so, we'll create an expanded version of our schema that more closely resembles the resources you'll actually be submitting to the Google Ads server. In addition, we'll populate our schema with the temporary resource names needed to submit bulk mutate requests. And in my experience, it's much easier to do this in a pre-processing step than it is when actually constructing the resources. With our expanded schema in place, we'll move on to operation construction. This step will look really familiar if you've reviewed our code examples. However, the approach I'll be walking through is a bit simpler because of the pre-processing, which also adds a bit of modularity. Finally, you can submit your request. And I want to point out that the approach we're taking affords us a bit of flexibility, so it should work in a variety of environments. You can submit requests one at a time in real time as you create each individual campaign. You can create a queue of operations, then submit them in bulk using a scheduled job or some sort of similar mechanism. Or if your infrastructure is sophisticated enough to populate the inputs of your flattened schema automatically from our earlier step, then you can automatically create and manage campaigns at a large scale, which presents some really exciting opportunities. In fact, that's one of the things I hope you get out of this talk. If we can systematize the mechanics of creating PMax campaigns, you can focus on more creative endeavors like creating campaigns or developing an automated system to accomplish just that. Once we're done reviewing the campaign creation pipeline, we'll shift our focus to campaign management with a specific focus on retrieving data about your campaigns and making updates. This will build on many of the lessons from the campaign creation process, such as structuring the data provided by the API. We'll also cover some of the major differences to consider when performing updates as compared with initial campaign creation. That's a lot to go through, and I'm really excited to share all of this with you. Let's get started. I'm going to skip the uploading assets part of our pipeline because that process is fairly straightforward if you're familiar with the API already. If you take anything away from this section, it's just what I said before. Upload assets that you may want to use in PMax campaigns ahead of time, and then select assets to include in your campaign later in the process. With that, let's take a look at the input generation and flattened schema creation processes. This visual might be one of my favorite parts of this entire session. Keep in mind, I've been educating developers about PMax for a long time, and nothing, in my opinion, more clearly demonstrates the components of a PMax campaign from a developer's perspective than this simple JSON schema. You can use a different mechanism or data structure for defining your PMax campaigns, but I like the idea of using JSON here because it is declarative, easy to understand, and language agnostic. Although I've made a big deal out of this visual, it's not a major breakthrough. In fact, this very closely resembles the structure of the resources you'd normally need to create in the PMax campaign creation process, but with a few key differences. First, our schema abstracts complexity present in the Google Ads API that we need not define for Performance Max campaigns, either because they're not related to PMax or the values are required constants in PMax. The Google Ads API was designed to be flexible and extensible, so you don't need a different campaign resource for each type of campaign. And this is exactly why we can use many of the same resources that you've come to know and love when managing Performance Max campaigns via API. However, some fields like discovery campaign settings are completely irrelevant for the sake of PMax, and others like advertising channel type will always be populated with the same value, which is Performance Max in our case. Second, in this schema, we are nesting resources associated with asset groups inside of the asset group objects, namely asset group assets, asset group signals, and asset group listing group filters. In the Google Ads API, these items are unique resources with their own resource names, and they are linked to asset groups via reference. As a quick side note, I won't be discussing asset group listing group filters in this session. Given their complexity and the amount of content we'll be going through, there just wasn't enough time. However, I went into considerable detail on the topic in the Everything About Asset Group session earlier. We have a thorough guide and a dedicated video on our YouTube channel if you want to learn more about working with asset group listing group filters in the context of PMax campaigns. Back to the schema design. I like this nested structure because it's easy to get a full picture of an asset group at a glance. Along those same lines, I'm hoping this view is a bit more intuitive. You'll also see later that structuring your resources in this way can greatly simplify resource name construction and management, especially when using temporary IDs in bulk mutate requests. Remember, this is required when linking assets to asset groups using asset group assets, because asset groups must meet all minimum asset requirements at the time of creation. That brings me to the next difference between this schema and the Google Ads API, which is this asset group info object here. This field may already be generating some questions for our highly astute viewers because the concept of asset group info doesn't exist in the Google Ads API. I made this field up for this schema as a way to encapsulate all of the assets associated with an asset group. Again, I found this made things a little easier to understand at a glance. Using this field will also help us process and validate our data in a later step. In addition, I should point out two asset field types that don't exist in the Google Ads API: short headlines and short descriptions. These address a special asset requirement that I'll cover a bit later when we discuss validation. The last difference I'm going to call out is what I'm calling the flattening of certain resources, which is where the schema gets its name. Perhaps simplifying is a better word, but we're effectively reducing these resources to their simplest forms. For example, our asset group signals are organized by type in each asset group's signals field. Each asset group signal can either be an audience or a search theme. Audiences are represented by a list of audience resource names, and the search themes field is a list of text strings, the actual search themes. You may also notice that our conversion goals are a list of category and origin pairs. I'll go through this later, but the process of setting campaign level conversion goals can be a bit involved. At the end of the day, we simply need to define which category and origin pairs we want as goals for our specific campaign. Explicitly listing these seemed like a much simpler and easier approach. Then, we'll just add some boilerplate logic to do the processing later on. The asset group info field is structured as a key value pair, with the key being the asset field type, which is set when creating an asset group asset. The value of each asset field type is a list of strings. Each string in the list will contain either an asset resource name if the asset has already been uploaded, or information about the asset if it hasn't. If that asset hasn't already been created, we'll create it on the fly after checking it meets the specifications for the given field type. If the asset is a text asset, such as a headline, this will be the text of the asset. If it's an image asset, the string will be an image URL. There are, of course, other ways to process and upload images, but this seemed like a simple mechanism for the sake of demonstration. I should also point out that for the sake of simplicity, asset group info only includes the asset field types that are required to create a valid asset group. However, I would encourage you to include additional asset types if you can to help with ad performance. Before I move on, I want to show you a few additional schema options that will be relevant later on. First, we have the option to create a PMAX campaign for online sales with a product feed, which I'll be referring to as PMAX Retail. To create a retail campaign, simply add the shopping setting field in the campaign with entries for merchant center ID and feed label, which are required for PMAX Retail campaigns. Asset groups in PMAX Retail campaigns also require a valid product partition tree, so you can nest a list of asset group listing group filters in each asset group. However, I haven't built support for asset group listing group filters and automatically create a single node tree that includes all products whenever creating a retail campaign. Finally, I want to show you some settings I built into the pipeline. One of my favorite parts about the validation step in the pipeline is that I've built in mechanisms to automatically fix certain errors by specifying certain campaign settings. I want to be clear, these settings are not part of the Google Ads API. They're only present in this custom pipeline application that we're going through today. If you exclude these settings or set them to false, any associated errors will block campaign creation altogether. However, setting these fields to true can automatically fix certain errors on the fly, so your campaign can still be created. Skip invalid assets will automatically drop any assets that don't meet the specifications for the given asset field type. For example, a headline that has too many characters. As long as you still meet the minimum asset requirements for the field type, we'll still submit the request. If you have too many assets for a given field type, remove excess assets will only take the first n assets that still meet the maximum requirement and drop the rest. If you set create empty retail on error to true, your asset group info is invalid, the validator will automatically create an asset group without any assets if you're creating a retail campaign. As you may recall, you can create an assetless asset group for retail campaigns. However, it's all or none. You either have to meet all asset requirements or exclude assets altogether. The skip invalid asset groups field will automatically drop any asset groups that can't be fixed by the aforementioned solutions. If you create a PMAX campaign with 3 asset groups and one contains an error, setting skip invalid asset groups to true will still create the PMAX campaign with only the 2 valid asset groups. Remove excess asset groups automatically drops any asset groups above the limit of 100 per campaign. If you try to create a PMAX campaign with more than 100 asset groups and this setting is set to true, the campaign will only use the first 100 and drop the rest. Finally, remove excess signals automatically drops any asset group signals above the limit for an asset group. Each asset group can have a maximum 1 audience signal and 25 search themes. These are just a few options I came up with based on my own experience, seeing how you all use the API. But you could also come up with your own settings. The goal here is to increase flexibility so that campaign creation is only blocked when you want it to be blocked. Now that we understand the structure of our flattened schema, let's take a quick look at the asset selection process. Without being overly prescriptive, let's review an approach that is flexible and reliable while also following best practices. And by reliable, I mean that you'll be able to more reliably use assets that meet each respective asset field type specifications, such as the string length for a text asset or the aspect ratio for an image asset. One of the best practices that I'm trying to encourage is uploading assets to your asset library you think might be useful in an asset group ahead of time, then drawing from that account level asset library in the asset selection process. As you may recall, asset groups have strict asset requirements as outlined in this table. So you'll need a mechanism to fetch a subselection of those assets and ensure you're meeting asset requirements. I would suggest using a GACL or Google Ads Query Language query that inherently filters to address asset requirements. For example, if you were retrieving existing headlines, you could use something like this. Then, check that you're meeting string length requirements. Many of you will prefer to pass text assets into your asset group directly as strings. Not to worry, I'll show you how to do that too. And if you were fetching image assets like marketing images, you could use a query like this, which has filters that address maximum file size and minimum dimensions. I would also suggest using the returned heights and widths to filter for aspect ratio. You can also add something like this, which filters on the name if you've created your assets with descriptive names. Finally, you may not want to upload image assets ahead of time, and instead include them in the same request that actually creates your asset groups and PMAX campaign. You're welcome to do that, and I'll show you exactly how. Now that we've populated our flattened schema, let's dive into the pipeline application. This file, add_pmaxcampaigns.py, is structured like most of the code examples we provide in Python and accepts three parameters: a customer ID, a schema path, which is the location of the file containing the flattened schema, and finally, an asset requirements path, which is the location of a file containing asset group asset requirements, as I've referenced several times already. In the main method, we load the JSON file containing our PMAX schema, save it as a variable named PMAXcampaigns, and call add_pmaxcampaigns. This performs the steps I outlined earlier in the pipeline overview, namely validating and fixing our schema, expanding the schema in a pre-processing step, creating operations, and then finally issuing a request. The first step, calling this validate PMAX campaigns function, returns a list of the valid campaigns in our schema, which we assign to the variable valid PMAX campaigns. We'll only move on if we have at least one valid PMAX campaign to work with. It's worth noting that this entire validation step isn't strictly necessary. If you skipped it and submitted your request with errors, you could just fix the errors after the fact and resubmit your request. However, there are several benefits of validating your PMAX schema ahead of time. You can catch and correct errors early. You can preserve campaigns with errors in draft form locally to fix later. And you also have greater flexibility and control over error handling. For example, you can display messages to users to fix any issues, and of course, you can use the settings I shared earlier to automatically fix some issues without any human intervention. Back in our validate PMAX campaigns method, we initialize an empty list for our valid PMAX campaigns. Then, we'll iterate through the campaigns, validating one campaign at a time by instantiating a validator class and calling the isPMAXCampaignValid method for each campaign. This method returns a Boolean, whether or not the campaign is valid. If the campaign is not valid, we'll log any errors identified by the validator and move on to the next campaign. Otherwise, we'll add the PMAX campaign to our list of valid PMAX campaigns, which is stored by reference on the validator class. If the validator identified errors in a PMAX campaign, this means the custom settings did their job and that our validator automatically fixed some errors. We'll still create the campaign, but we should log the errors to give ourselves an opportunity to investigate and address them in the future. Let's take a look at how the validator class works under the hood. Our constructor method begins by initializing a few instance variables: our PMAX campaign, the empty error list, and an isRetail variable, which is useful for tracking across the class, considering you can create assetless asset groups in the PMAX retail campaigns, as it was discussed in a couple of earlier sessions today. Finally, we load a file containing information about the asset requirements. In my example, I'm using a file called, yep, you guessed it, assetrequirements.json. I want to take a second to call out a few differences between the asset requirements you see on the screen and the actual documented asset requirements. First, I've split headlines and descriptions into two separate entries to account for the short versions of each. I discussed this earlier. Second, the cumulative maximum number of images allowed is 20. For simplicity, I've just split this evenly for the two required image types, marketing images and square images. Similarly, the cumulative maximum number of logos allowed is 5, so I've set the max to 5, even though this could technically be divided among logos and optional square logos. Now, let's take a look at the isPmaxCampaign valid method, which has two basic steps. First, we validate asset groups, then we validate the bidding strategy. There are, of course, other things we could validate, but these capture a number of common mistakes and illustrate several important points. The valid asset groups method returns a list of all valid asset groups after any automatic fixes have been applied. If the list is empty, we can return false because all PMAX campaigns require at least one asset group to serve. Otherwise, we'll overwrite the asset groups entry in our PMAX campaign's instance variable to capture any automatic fixes that were applied. Finally, we'll return the result of is bidding strategy valid. Most of the validation logic in this class is handled by the valid asset groups method and its submethods. And the main goal of this method is to ensure our asset requirements are properly addressed. At a high level, the process for validating asset groups is as follows. First, we'll validate the asset group info entry in each asset group. Then, we'll validate the asset group signals entry. We'll add any valid asset groups to a list called valid asset groups. If the length of our original asset groups list equals the length of our valid asset groups list, we know all of our asset groups are valid. If not, we can still proceed by leveraging the skip invalid asset group setting. Next, we'll validate the number of asset groups since there is a max of 100 asset groups per campaign, and we'll do so in the validate num asset groups method. Otherwise, we'll return an empty list signaling that we should not create this campaign. Let's see how to validate asset group info by stepping into the validate asset group info method. There are basically 5 possible states for our asset group info. 1, the asset group is missing an asset group info entry and is part of a retail campaign. This is okay because we can just create an assetless retail campaign. So we'll just return the asset group. 2, the asset group is missing an asset group info entry, but it's not a retail campaign. This is not allowed, so we'll return an empty dictionary so the asset group is not created. 3, the asset group info entry is present and contains errors, but we can simply create an assetless asset group in a retail campaign. In this case, we'll delete the asset group info entry and return the resulting asset group. 4, the asset group info entry is present and contains errors, but we have no path to fix this issue. In this case, we'll return an empty dictionary so that we don't create the asset group. And finally, number 5, the asset group info entry is present and entirely valid, in which case we'll just return the valid asset group. Now, let's walk through the method that validates the contents of the asset group info entry, validate asset requirements. First, we iterate through the items in our asset group info entry and flag any invalid asset types. Each entry contains a list of assets which are represented by strings, which is a resource name in the event the asset already exists in the Google Ads account. Otherwise, the string will be the actual text of a text asset or the URL of an image asset. If the string is a resource name, we'll assume it's valid because of the validation we performed in the asset selection process. If not, we'll check if the asset meets the requirements for the asset field type. For a text asset, this is just the string length. For an image, we need to check the aspect ratio and the image size, as well as the image dimensions. We perform the asset validation in a method called asset violations, which returns a list of any violations for the given asset field type. We use a similar strategy as earlier by adding all valid assets to a list, which will ultimately return. If there are any asset errors and the skip invalid asset setting is not set to true, we'll return an empty dictionary indicating an error in the asset group info entry. Otherwise, we'll validate the number of assets for each field. In validate num assets, we iterate through our asset requirements entries to ensure we're not missing any. Then, we check if the number of assets for each field type in our asset group info entry satisfies the min and max requirements for the given field type. We can adjust for exceeding the maximum number by using the remove excess assets setting. If we have an appropriate number of assets, when accounting for that setting, we'll return the possibly updated asset group info dictionary or an empty dictionary if not. We've now fully validated our asset group info entry. Back in our valid asset groups method, we'll know if it's valid if validate asset group info is non-empty, in which case we'll validate the asset group signals. This step is fairly trivial. We check if any of the provided asset group signal fields have more items than allowed. If so, we'll return the asset group. If not, and remove excess signals is true, we'll drop any excess signals, and if remove excess signals is not true, we'll return an empty dictionary, signaling we should not create the asset group. If we still have a valid asset group at this point, we'll add the possibly updated asset group to our locally defined list of valid asset groups. At this point, we have our original list of asset groups and our list of updated asset groups, which present three possibilities. The length of the two lists are equal, meaning all asset groups are valid, so we should validate the number of asset groups. The length of the two lists are not equal, meaning some asset groups are invalid, and skip invalid asset groups is set to true, in which case we should still validate the number of asset groups. Or 3, the length of the two lists are not equal, but skip invalid asset groups is not true. So in this case, we return an empty list, which indicates the campaign should not be created altogether. All PMAX campaigns need between 1 and 100 asset groups. If we've gotten to this point, we know we have at least one valid asset group. So we need to check we haven't exceeded the maximum. If not, we'll return the list of asset groups. If there are more than 100 asset groups, but the remove excess asset group setting is true, we'll return a list of the first 100 asset groups. Otherwise, we'll return an empty list so that the campaign is not created. As far as our bidding strategy goes, we need to check that the provided value is one of two allowed types: maximize conversions and maximize conversion value. In addition, we can optionally set the target return on advertising spend, but only with a maximize conversion value bidding strategy. So we need to make sure we're using maximize conversion value if target ROAS is set. Once our validation is complete, we can check if there are any valid campaigns to create back in our add PMAX campaigns file. If so, we can move on to our next step, creating an expanded PMAX schema. Here is a look at what I'm calling our expanded schema. Now, this schema is kind of like a hybrid between our flattened schema and the structure of the underlying resources that we'll ultimately be creating. You may notice that our campaign budget, campaign, asset groups, and asset resources all have a resource name field. Each of these will be temporary resource names, meaning they are created using temporary IDs. That's because we'll need to reference each of these resources in other resources within the same request. To that end, you'll see campaign now has a campaign budget field. Each of the asset groups now has a campaign field. Each of the asset group assets have asset and asset group fields. And finally, the asset group signals each have an asset group field. Wow, that was a mouthful. Each of the fields I just mentioned will be populated with the temporary resource name of the corresponding resource. The next change I want to point out is that the resources that were nested in each asset group now more closely resemble the underlying resources we'll be creating. To that end, we no longer have an asset group info field. This will instead be represented by a list of asset group assets. In addition, we now have a list of the assets that will be created as part of our request. Finally, each asset group signal is now represented by a single object rather than a list for each individual type. This schema still isn't an exact representation of the request that we'll ultimately submit. The biggest difference is that we're still nesting assets, asset group signals in each corresponding asset group, despite the fact that these are first-order resources in the Google Ads API. It's helpful to keep these resources nested like this to maintain the order of our operations later on. You could always reorder your operations list later on, but I find it's easier to preserve this order throughout. As a reminder, you can't reference a resource before it's created. And in the context of a bulk mutate request, that means the reference resource must come prior to the referencing resource in the operations list. In addition, you must list all of your asset group asset operations for a given asset group consecutively, as Mattia pointed out in his best practices session. Let's quickly walk through some code that transforms our flattened schema into an expanded schema. The expand PMAX schema function will be our entry point. We'll have to pass in the validated schema, which I've named PMAX campaigns, as well as a Google Ads client and customer ID so that we can construct resource names. We'll ultimately return the expanded PMAX campaigns variable, which is initialized as an empty list. Also note the global nextTempID variable, which is what we'll use to track the temporary IDs that we'll use to construct resource names. To that end, we'll also make use of a nextTempID function to decrement the temporary ID. Here, you can see we create the campaign budget and campaign objects, which is as simple as assigning the fields from the old schema to the new one, with a few key differences. First, we'll create a resource name using the temporary ID, and then decrement nextTempID. In addition, we associate the campaign with the corresponding campaign budget by using the budget's temporary resource name. We'll also expand our conversion goals, but all we have to do here is add a reference to our campaign. Things get a little more interesting when we look at asset groups. For each asset group, rather than just assigning the entire object like we did for our campaign budget and our campaign, we're going to explicitly declare which fields we want to assign to our expanded asset group, because we don't want all of the fields. We'll set the asset group temporary resource name, the campaign reference, and the status. Then we'll decrement TempID. Next, we're going to expand our asset group info object into two separate lists. we have a list of new assets we want to create as part of the request, and then we also have a list of asset group assets. This expand asset group info method will return a dictionary with our list of new assets to create and asset group assets. Let's go ahead and flip to that method. First, if there is no asset group info object, we'll return a dictionary with empty lists of assets and asset group assets. Otherwise, we'll iterate through the list of strings for each field type inside of our asset group info entry. And for each one, if the string is a resource name, we know the asset has already been created. Otherwise, we'll need to create the asset, which we'll do as part of our bulk mutate request. So we'll create a dictionary with the fields we'll need to do that. A name for the asset, which is required, an asset temporary resource name, and the asset text or image URL, depending on the asset type. We'll append our asset to the list of assets and decrement next temp ID. Now, regardless of whether or not the asset already exists in our Google Ads account, we'll add an asset group asset to the corresponding dictionary for each asset. This entry will contain our asset group reference and our asset reference, which will either be the original asset string if it was a resource name, meaning the asset is already created in the Google Ads account. If not, we'll use the resource name we created with the temporary ID. We also have to set the asset field type for each asset group asset. I've decided to use a little helper method here rather than the approach I've used to handle other enums thus far. The field names I use don't exactly match the asset field types, and we also need to assign short headlines and short descriptions to their actual enum types, headlines and descriptions. Once we're done iterating, we return our dictionary. Finally, we'll add our asset group signals to the asset group object. This is pretty straightforward. We'll return an empty list if there are no signals on the original schema. Otherwise, we'll loop through each list item in each field of the signals object, associate the signal with the corresponding asset group using its temporary resource name, then either the audience or search theme field depending on the type of signal. With our expanded schema complete, we can now create a list of mutate operations that we'll send to the Google Ads server to create our PMax campaign. If you've looked at any of our existing Performance Max code samples before, this should look somewhat familiar. It's almost like a deconstructed version of those examples. For each campaign, we'll return a list of mutate operations, which includes the campaign budget operation, campaign conversion goal operations, and asset group operations. Note that the asset group operations list includes the operations that create our asset group, new assets, asset group assets, and asset group signals for each asset group. We include all of those together to guarantee a valid order of operations in the overall request. As we look at each one of these methods to create our operations, you'll see why the pre-processing step is so useful. In the create campaign budget operation method, we create a mutate operation like we would for any other resource. What's nice here is that every field we assign is either a field from our expanded schema or a constant value that is required for PMax campaigns, such as the budget delivery method, which must always be standard, and explicitly shared, which must always be false. In addition, we've separated the logic that creates the resource names from the logic that creates our operations, which you'll see throughout. We could have taken the pre-processing step even further and just created dictionaries that reflect the full underlying structure of each resource as defined by the protos. And if you take this approach, you can even leverage helper methods in the Google Ads API Python client library that convert a dictionary directly into a resource. The create campaign operation method has a similar flow. We either set the fields from the schema object or use the required value, such as the advertising channel type, which is always performance max. The only difference here is that you have to follow this pattern to set the bidding strategy and/or target ROAS because of how that field is structured. In addition, we can set some optional fields and the shopping setting field for retail campaigns if it's provided. I'm not going to go into great detail for the create conversion goal operations method because we have an existing video that walks through this code flow. But at a high level, we're retrieving all the customer level goals in category and origin pairs. We'll loop through those as well as our list of goals, and for any category and origin pairs that are in both lists, we'll create a campaign conversion goal with the biddable field set to true. For all others, we'll do the same, but with biddable set to false. Finally, let's look at the method that creates all of the asset group and related operations. This parent method simply loops through each asset group and adds the operations for each one to a list that we'll return. The method to create the operations for an individual asset group is also fairly straightforward. We create a mutate operation for the asset group operation by setting the fields from our schema. Then we'll create operations for each of our assets, asset group assets, and asset group signals, and then return the full list. And also asset group listing group filters for retail campaigns, but as I said earlier, I'm not going to get into that. Again, all these additional methods do is iterate through each item in the schema, then set the fields on the Google Ads object from the corresponding object in the schema. Here is the create asset group asset operations method and the create asset group signal operations method. With this list of operations, we can now submit our request using the Google Ads Service mutate method, or we can also use batch processing. We can even add these operations to a queue to issue our request later if we'd like. I have a sample schema here. Let's give this a try. As you can see, I was able to successfully create 2 PMAX campaigns. That covers our creation flow, but I do want to take a little bit of time to cover reporting and updating. I understand that some of you may have sophisticated infrastructures with local copies of Google Ads resources and mechanisms to sync data. For our purposes, we're going to look at a simpler flow where you retrieve data using SearchStream, update objects locally, and then issue a request to update those resources. And for our purposes, I'm going to focus on efficiently retrieving campaign data that can be used to display to users and/or update your campaigns. In going through this exercise, my goal was to recreate as much of our initial schema as possible with a single request. To do that, I'm going to issue a query against the asset group asset resource because I can leverage the attribute resources, asset group, campaign, and asset. With that, we can recreate much of our original schema with the exception of our campaign budget and any asset group signals and asset group listing group filters. You can also enrich this schema with resource metadata or even performance metrics. Fields like campaign or asset group, primary status, and primary status reasons can also provide you with useful information about why your campaign may not be serving, which Mattia covered in his session earlier. Other fields like asset group asset performance label can tell you about how assets are reporting. I'm not going to get into too much detail since Laura already delivered an entire session on reporting. However, you can use this data to inform decisions about which parts of your PMAX campaigns to update and how. When updating resource fields, you can do this like any other update in the Google Ads API. Change the fields on the object you want to update, create an update mask using the field mask utility, create your update operation, and finally issue your request. However, you must take a different approach to update entities represented by discrete resources, such as the assets associated with an asset group. To add assets to an asset group, use an asset group asset create operation. And to remove an asset from an asset group, use an asset group asset remove operation. We don't have time to get into this today, but you could also leverage parts of the existing pipeline we reviewed today to construct a new update schema, validate the end state of your PMAX campaign, and then finally issue your request. We've gone through a ton of content today, and I hope this session was useful. Perhaps you'll employ some parts of the pipeline I shared with you in your own infrastructure. If nothing else, I hope this session helped bring together many of the concepts that we've reviewed today in a more concrete fashion, while also giving you a few tips and tricks to navigate PMAX campaign management with the Google Ads API. We're going to leave this session open for a little bit. Feel free to leave any questions or comments in the chat below. We have team members standing by to connect with you and help you out. As always, you can take advantage of our support resources in case any questions come up at a later time. Thank you so much for tuning in. I'll see you next time.